you can you can leave your you can be on camera if you know your where you are is a place where you can it's good. I see your face as well. So that most times when look as if I'm just talking to a ghost. So
I
if you
know.
can, and sometimes you can unmute yourself
Yeah.
so that it's good. So it would be like a real class. Okay. Yeah, welcome to this section again. Um, what we're gonna do, we're gonna try to see how to recap all we've done in our last class. And then if we can do that on time, we can quickly move forward to something else. So I will be sharing my screen based on what we did in our last class. Kindly enable me to share my
Share
screen.
your screen. Okay.
Yeah.
You can do that now.
Yeah, you can share my screen now. Please confirm you all see my screen. You can all see my screen.
Oh, yes. Yes, I can.
Okay, good.
Um, yeah.
Normally, before you start doing any of the analytics job work, what we normally do is we install all the packages that the necessary libraries that we'll be using for, yeah, all the necessary libraries. It is important we install them. For example, we are supposed to install something called a library called NumPy using pip install NumPy. But if you have installed it before, you don't necessarily have to be installing it every time. So on your system, you are supposed to have installed pip install NumPy. With time, we are going to talk about how to set an environment. Maybe after we are done with our lesson, with all the course, we'll look for a way to teach ourselves on how to set virtual environment. So when you have your virtual environment, you will have installed all the libraries you will be using for every analytics job you want to be doing. So you install NumPy, one of the libraries we use. You install pandas. You also install matplotlib. You install Seaborn, the Seaborn. You can also install we have installed matplotlib. Okay, yeah. You install Seaborn. So, okay, then for your Excel file, if you are going to be using Excel file, then you install OpenPySL. There are other libraries that we also need to install, but for now, this is good. Now, after you have installed them, then the next thing you do is to import them. How to import them? We say import the library we want to use, import pandas as PD. Assuming I want to use Seaborn, I will import Seaborn, import Seaborn. I'm expecting it to bring it for me. Seaborn as SNS. If I can also import matplotlib library as well. But for now, I'm not importing anything for now. So what we did here was that we are trying to curate our own data frame. To create the data frame, we say, for example, if we have set of 10 students like this, David from David to UBA to Uber, these are our students. We have, and this is how to get a list. If this is our list of students, we have this as a list of students, and then we define their score. Each one of them, of course, they are 10 in number. We are supposed to have 10 entries here. So we define a score for mathematics, um, Chemistry and biology. These are their respective scores. I can change this if I like. I don't want this to just be having 50, 54, 54, 54. So if I like, I change this one to 82, 83. Let me change this one to 76 or maybe 66 or maybe 56. So we just define them. All these are just quick method of getting our score. These are all the scores for them. We can define more other parameters. For example, I still want to define something like maybe their cells. Okay, let's just define their cells. For example, if their cells, let me say David is male. Okay, since it's a string, like male. Another person, let me have Haisa, let me say female. Let's say Bola, let's say male or female. So this time around, I decided to use capital F alone. Let's say Philemon. Let's say Philemon, let's say it's a male. So I can put male. Let's have Rur as a male as well. Can be anything. Let's just put male. Let's have Anthony as male. Let's have Ahmed as male. Let's have Lillian as female. Let's have Ethel as female. Let's have Uba as male. Let me see the nature of male I want to use. Okay, it's the one I can say male. So let's put their age as well. Age. So if this is their age, we have the age. 60. Okay, this is a class 23. 16. 32. 23. Okay, let me say 24. 25. 25. 29. 1, 2, 3, 4, 5, 6, 7. 30. Wait. Let's say 18. And let's say 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these are their ages like that. So now, if this is a list, we say all these are different lists we have. We say we can combine this list to form a dictionary. If we get this list and we use it to form a dictionary, we can from there form a data frame. So this was how we form our dictionary. So we use this as the key for the dictionary, and at the same time, we use the respective data as the values for the dictionary. So let me add this new one. I have this time around, this is the key. I have another key that was not in the former one, the original data we used before. So the cells, I can just copy it. So after that, okay, I should have a comma. Another one. We now have age this time around. We are trying to form a dictionary and use the dictionary to form a data frame. So their respective age, we have the ages. This is their age. So if I run this, I have a dictionary. I now say, after getting our dictionary, we can turn this dictionary to a data frame. If I just print this dictionary like this, I just say student div. If I print the student dictionary, if I print this student dictionary, you will see this is the dictionary we have. You see, we have a dictionary with a student's name, math score, chemistry score, biology score, size, and age. But we don't like it this way. We want it in a tabular form. So to get it in a tabular form, we're going to use pandas, pandas data frame. So, well, we import pandas, we import NumPy, we import Cbond because we're going to use all these during our data analysis. So now, since we imported the data, the pandas, we can use this module data frame to turn the dictionary to a data frame. I run it and I call it student data frame. This is the name I just decided to call it. So if I run the student data frame, the dictionary has been converted to a data frame. And this is the data frame that contains the student's name, the math score, the chemistry score, the biology score, their cells, their age. So we continue by saying that we can also add another column to our data frame. The data frame contains the number of columns, 1, 2, 3, 4, 5, 6, 6 columns, and about 10 rows. Now I want to add more to my column. There is a way I can add more, and this is another way to add more. I've created another list. This is another list we call geography score mark. So I can add that geography mark to my data frame, and I want to call it geography score. So this is the geography mark. So I put it here, and then I call the data frame. The name of the data frame is student data frame, and I want to put another column that bears geography score. So if I do it like this, it's going to take the old geography mark and put it as another column at the end of our age. So after the age, we are now going to have another column here. That is the head. And the column we are having now, we are creating another column, and we call that column geography score. So if I run it, at the end, I run the student column now. The student column should now have another thing called geography score. So this is how to add another column. If I want to add another one, I'm still going to define another list and then add it this way. Call it the name I want to call it. So I can continually continue to build up my data frame, increase the number of columns to whatsoever I choose to. So now, the next thing was that we added another one. We said, let's add another English mark. For this is another thing we wanted to add. After running it, it has been added. So by running it, it's going to be added to the column again. So after the geography score, we now have another one called English score. Now we can continue to build this data frame, and we have more columns. Now we say after we have gotten our column, one of the things we can do is, or the first thing that is good to do is to check the shape of our data frame. And checking the shape of our data frame, we say we can call .shape on it. So calling it, if I run this student data frame .shape, is telling us that we have 10 rows, 8 columns. So if I check the data frame, now you now see that in this data frame, I have 10, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 columns and 10 rows. Of course, you see 9 here, on the index 9, but you know, the index starts from 0, so automatically is 9 plus 1, that is 10. So, and that is what we have just confirmed using checking the shape. In some cases, you don't even need to do that. Immediately you run the data, it's going to automatically tell you what the shapes look like. For example, I have one we run last time, and this is, for example, if we check this is already telling us that we have 19021 rows and 77 columns. So if you check, you will see that this is a big data, a large data that contains 77 columns and about over 19,000 rows. So even we don't even need to call on shape checking the shape. We can get that at the end of the table. So let's go back to what we are defining here. So after running our shape, we already know, but we know that in some cases, we don't even need to do that. It's going to tell us that this is what we have after it has been imported. So it's going to tell us that we have this number of rows and this number of columns. But whether we have it or not, we can as well call on this method to check the shape of our data. Now, after running, apart from checking the shape, we say other thing we can do is to check on the data type of the data we have. Each column, for example, the student column should be an object. Of course, we have talked about the data type we have the other time, that we have a data type of float, integer, we have string. Anyone that is string like this, these ones that are string, we call that it is going to be seen as an object. If it is not a string, if it is number, it's going to be seen as an integer or as a float, depending. So let's check on the data type. So we check on the data type. Now it's telling us that student data type is object, maths is an integer, and chemistry is integer, biology is integer, the cells is object, of course, male, female, they are object. Age is integer, geography score is float, and then English score is also object. Now, from here, we already know that something is wrong with our data. The data type is mismatched. This data type can be said to be mismatched. For example, the student's name should be an object. Yes, should be an object. But the math score should not be an object, should not be an integer, because someone could have scored 77.5. So it is better placed on float rather than an integer. So it is better placed as float rather than an integer. Therefore, there is a way we can convert from one data type to another, so which we are going to see later. For example, biology score is also integer, which is wrong. The cell is object, yeah, because it's either going to be male, female, so those are what we are supposed to have. This is correct. Age, yeah, age is correct. There is no age of float. You say my age is 20.5. So that except you want to talk about in months. So if you want to talk about your age in months, you convert everything to months. So you know the age is going to be in months. But if you are using year, then definitely it's going to be an integer. It's going to be wrong to say 1.5 years old. 1.5 years old. No, so it's better to be an integer. It means the age being an integer is correct. The cell being an object is correct. Now, geography score is float, which is good. It's better than the biology score, chemistry score, and mathematics score that are integer. So it is very important now that we convert the math score, chemistry score, and biology score to the type float of like the geography score. Then the English score is an object. No, English score cannot be an object. It should rather be a float. Integer is better, but float is the best data type that will go for this type of data we are using. In some cases, of course, like age, it's better the age is an integer, but the other score should better be in floats. Of course, the student name should be an object. So we know in this data we have now, we already have a mismatch data type, and later we should talk about how to convert from one data type to another in a data frame. So that is the problem number one we're having with this our data. We can also check for another different. We can also check if we have other problem. We have imported Seaborn earlier, so I don't need to import it again. It has been imported before I started. Okay, I've imported Seaborn. When Seaborn is meant for you want to plot a graph, a chart. So you can import Seaborn or Matplotlib is meant for visualization. So that is why I imported Seaborn. So now here I want to, another thing we want to do is we want to check for if there is a missing number, digit, missing value in our data frame. If you check this data frame, this is our data frame. If you check it very well, on this column, on student name column, there is no a student without name here. On the math, there is no student without score. On chemistry, there is no student without score. But when we get to geography, you discover that there are some that are NaN, that is, there is no value. There is no value for them. There is no value for them. Maybe the student did not come for the test, or the student is having a missing value, or somehow the value was not recorded. So it was read as a non-value. So you see NaN, and here as well, under the English score, we have some of the students, like Bola here is not having a score for English language, and the same thing for anatomy, and the same thing, it's not that Anthony is not having score for English score, and Ahmed also not having a score for English score. This particular Aisha is not having score for geography score. So we want to check in our data, is there anybody that, of course, we can see? This is small data that we when we look at it, merely inspection, you can see it. If it's a very large data, you are not going to be able to see it. So you should be able to check if you have such a value in your data. So one of the ways to check it is to use graph, is to use chart rather, the heat map. So if I run this heat map, the heat map, this is how to run a heat map, SNS, which means Seaborn. Of course, when we were importing our Seaborn, we say import Seaborn as SNS. If you look at it, Seaborn as SNS. So if I did not import it as SNS, it means instead of saying SNS, I will say Seaborn. So we always want to use the shortcuts. So that is why we normally, and this is the convention for it, SNN. So anywhere you see it, you understand that is using Seaborn. Now, we say the Seaborn, check the heat map. This is our student data frame, the data frame we created, and check if we have a null value, is null. And if you have a null value, let's know. So if there is, once you run this is just a code you can copy, and you only change, this is the only thing that we change anytime you want to use it, the student data frame. Depending on the name of the data frame you are using, you only change this from your code. That is the only thing that will be changed, and you are going to get the same thing. So now, once you run it, if you run it, it is expected that everything is supposed to be the same color throughout. So it means since this color is purple, the whole thing is supposed to be purple. On your home system, it can be green, depending. So if it's green, the background is green, it means everything's supposed to be green. If it is yellow, it means everything's supposed to be yellow. But now that we now have other color that is different from the background, it's telling us that there is a null value. telling us that under geography score, we have a non-value. Under English score, we have a non-value. There's a non-value. That is why we have the yellow on them. But if you check age, there is no non-value. If you check sex, if you just check every other one, it is pure. There is no any other color on them. So which shows that if you go back to our data frame, we are going to see that on geography, we have a non-value, and on English score, we also have a non-value. But let's do something. Let's quickly do something here. Let me change part of our, let me change this size to a non-value. No, I don't want to change that. Let me change the one that is far away from, okay? Let me change a score here under the mass score. Let me change it to a non-value. This first one, np.nan. Let me run it. Let me modify the, I'm trying to modify the data frame again. I have to run it back to get to, yeah. I'm trying to modify it. So if I modify it now, you will see that everything will now change. It has been modified. So let me run this again. You have to rerun. Okay. Under mass score, I'm not seeing it. No, okay. I've not run this. Now, if I run this, you will see that under mass score, there should be any, I can't find it. What happened? Which one do we change? We change the mass score. The first one was changed. Okay, I don't know. Now that I've changed it, it's supposed to change the data frame under the mass score. Why? It's not changing. It's not changing. I don't know why. I've actually changed it. MP. Oh, the reason was because I did not import this before I run it. Maybe let me run this. NP is not saying the NP. Normally, the importation is supposed to come first before anything. So you are supposed to import all the libraries before you run anything at all. So I think it should run now. I don't know. Student dictionary. Oh, why? Okay. Okay, let me add, okay. It was yet to be a data frame here. Yeah. So, but let's just continue with what we are doing. What I was trying to do is that I want to modify such that you will see that there will be another dance here. But what I can do is I can create another data frame that is full of NA, yeah, and add it. After this, let me run this and create another data frame that is full of NA. Yeah, let me come here, create another data frame that is full of NA. Let me just say, let me just put it as error. Error is equals to, that is the name I want to call. Error is equals to, let me just create as many np dot non-value. So I want to create everything to be non-value in 10 places. Okay, let me just add number somewhere. Is it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Okay, I want to run this error and add it to the data frame. Let's quickly add it to the data frame. Let's call it data frame student. Student data frame. I want to add another column to this student data frame. And I want to call it error. Let me use capital error for it this time around. Error is equals to error. Okay, I'm supposed to put it in code. So is equals to error. So it's going to create another column that bears that name. So if I run it, another column should have been created. Let me run the student. Yeah, now the student data frame will now contain error. So if I run this now, you will see that in the student data frame, there is an error. There is another column called error, you can see. But sometimes, somehow I want to bring the error forward. Let me quickly rename. I don't want all the one that have, I want to rearrange this column so that the error should be somewhere around maybe after student name. Yeah, I want to rearrange it, bring the error forward before the mass score. So let me quickly create an empty space here and get all the columns. There is a way I can get all the columns. I just say the data frame, the student data frame, that is the name of our data frame, dot columns. Dot column is going to print all the column for us. Dot column, what is the spelling? Dot columns, okay? So if I run this now, it's going to bring all the columns for us. That is, the first column is student name, followed by math score, followed by chemistry score, biology score, what do you call it? Cells and age. So what I can do is I want to rearrange all these. I still want to call it a student I want my student column, let's say, to be equals to this time around. I need all these. Okay. So I need all these. Let me just bring this so that I have. Now, this time around, I want this to come forward. I can just copy it, delete it from here, and put it at the position I want it. Okay, let me say I want to put it here. Yeah. I've rearranged. If I run it now, I've run it. Oh, what is the error? Let me check. Let me check what the error look like. Okay. Let me see if I'm not, let me just run this and see why. I'm trying to, what I was doing is I'm only trying to bring the color. Oh, Control C. Student name, error, math score, chemistry score, this. Okay, let me see where the errors is. So does this, I don't know. We should be able to do this, except if I don't know what that would be. Okay. Did I copy anything wrong? Okay, I'm coming. Let me run them one after the other. Or let me type them myself. Let me just do this and see. Of course, this should just index this out. Okay, you can see this one run without any problem. Oh, then what is the problem? Okay, maybe because I have a lot of them. Let me put it in double bracket. Yeah. Sometimes because it's not just only one, it may require the double bracket. Yeah. Square bracket. Yeah. Let me put it in square bracket because I now have many stuff in it. It's not running. Okay. I don't know why this have to happen like this. Let me type it one after the other and see, because sometimes when you copy, I don't know, sometimes you may just copy a code that is not good for it. So let me run this first and see what I got. Let me run. What again? Just delete this column and rerun again. Sorry, there is something I actually wanted to get out from it. So that is why I need to do this. Student dev. Okay, let me pick a column and run. Of course, this is indexing. Oh, yeah, I got what happened. You know, I've sliced it before and I have to rerun it again from here to go back to, yeah, I have to rerun all this again to go back. Yeah. If I don't rerun it, it won't be able to see them the actual, yeah, I got what happened now. If I don't rerun all this, it's gonna be a problem. Yeah. So sometimes when you have altered any of your part of your data frame, if you don't run them from the beginning, it's always going to give you an error. Okay. Now this is where it was curated. Yeah. Now, before I start doing anything, let me quickly copy this. Let me just copy the data frame so that I will not have to be running it. Let me just say is equals to copy student data frame dot copy. Yeah, let me just copy it. Let me call this one so that I will be manipulating one. I don't need to be running everything from the beginning. So if I want to work on student copy, yeah, let me be working on this student copy now. Let me be manipulating that one so that running it afresh, yeah, is a copy of the original one. So anything I run on this will not affect the other one. So since I've copied it, now I want to run student copy dot column. So these are all the columns in the student copy. Now I still want to say let the student copy be equals to, I want to rearrange the student copies column. So this time around, I will put it in double bracket, square bracket. It's still the same thing I copied. I just, this time around, it's only that is in double square bracket. Then I will now change the position of this error. I think it should work now. The one major thing is that here you always come across error and you try to figure them out. So if I run this now, the positions will have changed. Yeah, I've been able to run it. It runs perfectly. If I call on this student copy, if I call on this, the error will now be between student name and mathematics. Even if I want to rearrange every other one, I can just rearrange them. Okay. Yeah, I want all the score to be together. Let me still rearrange this. Yeah, I want all the scores to be together so that, okay, this is the only thing you're gonna do. Yeah, it means I have all the score together, the cells somewhere. Okay, let me run again. Yeah, let me now call on the student. On the student's one copy. I've now changed what I'm working on. Student one, that is what I'm using. Why I'm using student one? Because if I have any reason to go back to the original data, I will call on student data frame. Oh, yeah, it's not why student one? What is the problem? Okay. This student one, I did not put I didn't put the data frame there. So it's only giving me the okay. So this from the student one data frame, rearranged that way. So it's not, oh, what is the problem again?
It's from the student data frame, not
Okay,
student
not
one.
student one. Let me check. I don't know what the problem is. Okay, yeah, from the student data frame. Now, the student one now. Yeah, good. Thank you. So you have to, we always come across all these problems, and sometimes we have to even shut down your system and go and sleep, come back to it. So you can see we have been able to rearrange our score together, put this at the other side so that we know when you are dealing with the score, you know that they are always together here. So then if you want to talk about 7, 8, so it's better this way than the student data frame now. This is better. Now, why I did it like this, because if I want to check the NA number in the NA non-value, you will see that there are some parts which will be far apart. It won't be joined together like the former one. So that is the aim of what I actually wanted to get out here. Now, this time around, we now have 9 columns and 10 rows. 10 rows, 9 columns. So if you check on this, there should be another one that will be student, that will be error. The error is float. Okay, rate the error as float. Now we are checking for this. This is what I only want to do. I wanted to separate the yellow from being together. That some parts, some other yellow will be on another part. So if I run this now, you now see that oh, well, the student, oh, the error, those that have errors, they were brought together. Yeah, those that have a non-value, even if they are far away from the from in the data frame, those that have errors were brought together. So that is, all these are had error, like error in error, non-value in error, non-value in English score, and non-value in geography. Okay. Anyway, now apart from that, we say apart from visualization using heat map, we can also use this code. Remember, we are using student one now, or we can as well be using this the F. It's still the same. So if you use the F and we run it, it's going to tell us where we have, okay, but let's use one, since we are already using one, student one. If we run it, it's telling us that we have error we have a non-value in error, we have non-values in English score, we have non-value in geography, telling us the number of non-values we have in there. And if you go back to that data frame, you actually see that in our error, we have like 5 non-values. So, which is telling us that we have 5 non-values. It's different from this. This one is only telling us that it's just a quick check. Is there any, if everything is purple throughout, in your home system, it may be green throughout, then you know, oh, there is no non-value. So now, if you check this one, it's telling us that in this, we have 5 non-value. Just use any one that you think is good for you. And at the same time, you can check the percentage of non-value. Instead of knowing the actual number of non-value, you can just run this to check the percentage. The only, oh, I'm using 1. We are going to be having this error if we don't, I'm using the F1 now. So the F1, that is the only thing you will be changing. If you want to have another data now, you will only be changing the name of the data frame. It's the same code throughout. So it's telling us that 50% of the non-value are in error, and 40% are in geography, 30% are in English score. So telling us we have no value. Now we wanted to create join another column to our data frame, and we call it this time around, we call it student matrix number. So the data frame we are using is 1. So we join this, and now if we check our new data frame, there should be another column called matric number after age. We can as well bring this matric number to, if you want it after the student name, we can just do the same thing we did the other time. All we just have to do is just to, let me create another space here. Oh, sorry. Okay, it's just to call for the column, student one column, oh, column again, dot column, dot column. Then if you run it, you see the columns again, then you're just reason like, let the matric number come after student name. So we can do that as well. Now we can just rename, we may not necessarily rename the student one, so, but we still say from this student is equals to the same student one, and now we want to rerun this. Remember we use double column, is equals to this, since I copy along with it. Oh, comma. So I want matric number to come immediately after there may be error. You know why there will be error? Because I copy. I realize when you copy the bracket, the square bracket will always copy a bug along with it. So if I don't want, I want the student's matric number to come here. Okay, but I think this is going to give me the same bug. So let me just remove it and put, I don't know. Okay, and put this. Of course, two of these. Okay. Okay, I don't know if it's going to give a bug or if it's not giving a bug. Okay, let's run. Okay, it's running perfectly. Let's call on our student again. It means the matric number has been rearranged. The columns have been rearranged. So you do this one by yourself manually. You just copy and put it in the position you want. So it's logical to have a student name followed by matric number, or matric number followed by student name. This is logical. So now the next thing we check was that we want to drop, like I'm a teacher and I don't want to see any student name. I don't want to, there is nothing I want to do with your name. All I need is your matric number. So because normally as human being, you think you're going to be biased when you see people's name. So of course, you may know some people's matric number, but it's not going to be as perfect as knowing people's name. So matric number, perhaps just know one or two people's matric number, but you can know almost half of the student's name. So you don't want that. So all you want to do, you want to remove the student name so you can drop a column. Any column you want to drop, you drop them. So the only column that is not relevant to me in this particular data is student's name. I don't want their name. So I just say, okay, go to my data frame 1 and drop the student name. Axis set to 1. Why the axis was set to 1 is because we have both rows and column. This is a row and this is a column, the column name, and we have the row. The row is is 0, 1, 2, 3 to 9. That is the index on the row. Why the index on the column, we call it, let's just say the index, column index. We say student's name, matric number, error. So we are saying check the column and not the row. So the setting your axis to be equals to 1 is only telling us that we are dealing with the column. If you are not setting it by default, I think it's going to be considering the row, or you set it to 0, 0 and 1. And in place means that if you change it in the original data F1 should be permanently changed. So if I want to drop it, if I run it now, it's going to drop the student name from student data frame. If I run the student data frame again, there will be no student name in the, you can see it has been removed, and we now have matric number. So we know how to drop a column. After dropping the column, we say another thing we can do. Let me just delete this since we don't need it. Another thing we can do is renaming the columns. You can rename your columns. How do we rename a column? We say when we want to rename our column, getting and renaming a column, we already know how to get the column. Of course, we just run the students dot columns, and after that, we can just say dot rename. When we set dot rename, immediately you set dot rename, you set the name you want to reset, you want to change. For example, math score, we want to change it to math score, like this. So when we run it, let me check, I'm coming. Excuse me. I actually want to check another name for you. Because that is not the only way to rename. I have another way that we can rename our column that will be very easier for us. Anytime we want to rename in a very easy way, there is another way to rename the column. Just want to copy the code. Don't want to. If I can find it, I just copy it. I store it as easy rename. So with time, you only build your library for yourself, what you think you will need when it comes to when you are dealing with any data. You just go to the library that you have on your system and be picking them just to replace the data frame. It's easier. So the most important thing is just that you understand what you are doing. Once you understand, then it is easier to do every other thing. If I can't find it now, let me check. There is a way I used to rename again apart from this that make it very easy. And sometimes when you are reading and you come across anything you think is important for you, just copy it, keep it somewhere, try it, run it, and if it runs well, try it again on several occasions, and then you put it in your library. Yeah, I think the best way to rename, yeah. Are you with me? Hello, everyone.
Yes, we're able
Yes,
to.
Can you
yes.
see my screen?
Yes, we can.
So we have renamed this. Let's first deal with this first rename, and let me try if okay. This is the first rename that we have done. We have renamed we only renamed, what do we rename? We only renamed math score to math score. As well, we can change every other one as well. So, but we only want to consider that one first. So initially it was math score written together. Oh, F1, sorry. Yeah, it was math score, just like chemistry score like this. But now we have renamed it to math score. So another way to rename, yeah, let's try again. There is another way we can rename. So I think that one is even faster. Let's call on the F dot the F. Student student data frame 1, right? Dot column. Let's see the columns again, because if I don't see it, it may be difficult for us to know what the name should be. Dot column. So let me run it again. So now these are the names. So assuming we want to rename, so what do you think we should rename them to? So all we're just gonna do, we're just gonna say this. We're just gonna take the student that column, exactly the column we have, and then we put all the columns. You see, these columns we have is the same thing we run. We now say is equals to, we now want to equate them to something else. So let's just copy this. That is what it was before. So this was what the same code gave us before, but now we now want to manipulate. You can now manipulate it. Like, okay, turn the math call and the math. What can we use this one? What can we call this one? Maybe we should call it matrix number. Matrix, let me put Ivan there. Number, right? Do you prefer it that way? Math score. Let's call this one chemistry score. There is nothing I did. I only call the student column. I put it again. I call this one just to be able to copy everything from the code. So I copy it, not to be typing it one after the other. Then I now say, okay, that student column gave us this. I put it at the front. This is what it gave us. I now say, okay, this thing you gave us, I want to change it to something else. So you now manually manipulate it. Okay. Biology, let me say this is biology, biology score. If I like, I can complete it. This is exactly what I just want it to be. Geography score, I want it to be geography score this time around. Geography score. So in either you use the first method, I hope there is no error in this one, but I think this is more faster. Either you use the first method or you, okay, even the cells, I want to make it capital S, or in fact, I want to make everything capital letter, like this cells, and then I want to make this one H. I hope you understand. Hello?
Yes,
Are you all
yes,
with me?
yes, we are following.
Yeah, I think this is better than the first one, right? It's easier to manipulate this. So if I run it, there should be no error. Yeah, there is no error. So if I run student data frame again, student data frame, the F1 again, all the columns should have changed to, you can see, to what I changed them to. So now you now have error, math score, chemistry score, biology score, geography score. I think this is more readable. Okay, the geography score is having iPhone instead of is having dash instead of iPhone. I don't know the one that is better. So if I think this is better, let me rerun and rerun again. You can see. So this is, I think this is better. This is how you continually format everything you want to format. So we've been able to change formats to our choice, to what we like. And if you like, you can remove core and just call it mathematics, chemistry, biology, because in your data could have been the score of student in, so depending on what you want to call it. Now we say initially we had problem with the data type. We say the data type, when we run the data type, we discovered that we have problem with some of them. Like for example, matrix number can be object, of course. Matrix number is object from here, because matrix number is 006 EDC. Maybe they belong to a particular education department, or they decided to say 006 ED6, ED something. Yeah, it's a combination of number and maybe alphabet. So it's good. It can be an object. Error. I don't even want this error. Of course, I will just remove it. Even before then, I can drop. I don't want it. Let me drop the error. Now I don't want the error. I can just call on my student, because it makes no sense to have that in my data. So I just call on this student stuff and say, is equals to, okay, dot drop. Oh, drop, what's it gonna drop? What are we dropping, man? Let's just copy the first code. Where do we drop? We drop, okay, this was how we dropped the other time. Just copy it and replace, so you don't have to disturb yourself. You just copy. Majorly what you do, you have some of this library you kept for yourself. Most of the things you think you can be working with, then you just be copying, them and then replacing whatsoever you want to do. So this time around, I want to drop, what are we dropping? Error. So you just copy it, because if you write another different error, it's going to flash back an error for you. So I want to drop the error first before I even check on that. Okay, let me just put it here. Okay, now if I run this now, it's going to drop it. It's gonna drop it. So if I call on the student one again, it's gonna by now it will have been dropped. So the error has been dropped from I don't want it. So it's been dropped. So I now have a pure thing that I want to work with. So now, if I have this, I run the data type. You already know how to run the data type. It's telling us that matric number is having objects. Is objects. Math is what do you call it? Math score is integer. Chemistry score is integer, and biology score is integer. No, which I don't want. So I can change all these. All I just have to do is to copy, is to change them to what the desire. If I do like this, I want to change them to the desired data type I want. For example, I want to change sorry. I want to change what do you call it? Matrix number, I don't want to change it. Math score. I want to change it from integer. This is math score. That is what I want to change. I want to change the math score. If I put math score here, it's going to change the math score in my data frame. So it's going to change it to float. At the same time, I want to change the chemistry score. It's going to change it to float. If I put chemistry score here, I want to run all of them. Chemistry score, change the chemistry score to float. Which other one I want to change? I want to change the biology score to float. Just copy the name. I want to change this to float. So if I run it, it has it was successful. So if I go, let me create a space. I've run it and it was successful. If I go back to I run the same code again to call the data type. Let me just run this data type again. You will just, this data type will have changed. You discover that this data type now will change. You see, the math score has now changed to float, chemistry score has changed to float, biology score to float, geography score float, but we still have English score as an object. If I try to do that, it's going to give us a problem because the English score here, if you look at, we have two problems with the English score. One of it is having O instead of 0, and the other one is having a special character like for exclamation. So if I run this, if I try to run on that, because all those things will not permit me to run this will not permit me to run this change on special character. So let me try to run on English language, right? This is what we call it. If I run this on English, let me just run. It's going to flash back an error because that is not. It is not a pure. I have to claim this. I have to remove the space. Yes, it's still going. That is another error. Okay. But the only error I'm going to have now is going to be the area of type conversion. It's not going to be able to convert that. Okay, you can see it's an error. So which will be a type conversion now. Okay. Okay, we have an error here. I don't know what the errors will be. Well, of course, I already know what the error is. The error is just because I have special character. I have this special character. I also have another one. This is a numerical. This is not 50, it's 50. Now, maybe this someone want to write 50 here, want to write 50, and now write O. This one's supposed to be 41, and mistakenly, you check your system, and press shift, and then instead of 41, it becomes 40. You can manually check, inspect this particular column. Let's see what we can do. There are so many things we can do on that question. Let's check. It means the column, this particular column frame is not numerical. It means every there is not numerical. So let's see. Let me quickly create an empty okay. Let me just call it from this inside English core, I want to see special character. Let me call it special string. I want to see a special string. Let me call it for now, I don't know what the special string is. Let me just say it's an empty list because I don't know what is there. I will now say, okay, let's try to run if. If okay, let's start for every column, for every
Excuse me, Abdul. Is on the type conversion.
Yeah.
If we want to do it all at once, can we build a dictionary?
Yeah.
Of column.
We can do it all at once.
Yeah. We can use a dictionary.
Yeah.
Okay.
Yeah. There are so many methods you can use. In fact, you can even run a function on it. You can run a function to call for every column that is numerical. You understand?
Okay. Yeah.
So there are so many methods, but this is just you have to understand all these optimize your code. Yeah. So it's better you a simple way that you can just go back, optimize your code. Of course, this is gonna be an heavy code for now, but you can always optimize the code. Before one major thing you do when you are developing any stuff, what you do, you just use a simple approach to run when everything is successful. Now you can now go back to every code. Okay, what can I do here to make it more perfect or more you understand? So, but for now, this is good for understanding. Everyone will understand this. So later, if you want to optimize, it's up to you. You can go and optimize it yourself. Okay. Thank you for that. Now, what I want to do here now is that I just want to check, like, okay, for every column, okay, let's see, every column in for every data or for every value, anyhow, every value in this English column, in this column. So, and is in students. You check student F1 and you go there and you check for, of course, we are only considering just only one value column there. That is the English column dot values. Of course, we can always use dot values on it. For every values in the English core of this data frame, of course, we are only, of course, you know how to index, just to bring out one column from all the other columns. For this, check if the value which we call var now is numerical. I don't know if numerical should be the best thing I should use, or is digits. Let me use its digit and say if var is digit, let's say is digit. I want it to come out. Is digit is not coming out for me. I want to see, of course, how is digit will be written now. But I'm gonna do typographical error. Let me check if I have his digit somewhere. I think it's digits. I'm not sure if is digit. It should be its digit. Okay, but if I'm not sure, I will only try it.
Abdul, I think it's number.
No, we have numerical. Let's
Okay.
just, I think it's digits. Let me try its digit and let's work on its digits first. If we have a value, if value values is digits, yeah, I'm looking for the best way to call it. Value is digit. What should happen if the value is digit? Oh, it's not saying it. It's not saying it. Okay. If value is digit, there should be its digit. Okay, let me see. I'm trying to find a good okay. I think there is string dot is digit. Yeah, I think there is string dot is digit.
Abdul, you're right. I checked. There is digits.
Yeah, it's digits. Yeah.
Yeah, it's digits.
If
It's
value,
digit.
but I don't know why it's not. Let me do this. If values dot is digit, let me see if this will work. Yeah. If there is value dot is digit, if not, yeah, not value is digits. Let me see. Let me first try what this can be. Let me just append. Let me just say special character, special string dot append. Let's run. If it doesn't work, dot append value. If I will explain, if let me see. Now let me run if it runs. Oh, you can't take that.
English, the int score.
Okay, int score
is not in quotes.
Okay, yeah, thank you. Thank you. Yeah. You see? That shows you're following well. Okay, okay, that is not even the problem. If value, if value is equals to, let me use this, is equals to value does this, let me see, append var, let me see if it works. It's not working. Oh, I don't know. How do we get those that are not digits? Because I just want to get it out. Oh, from this value, we need the value that is not a digit from this English score. In this English score, if there is a value in English score, let's print the value it's going to print. Now, let's see those values that are not a digit. If, okay. If value is digits, let me check. Is digits, it's not bringing it. Okay, let me say it's numerical. Okay, no, it's numeric. Let me see this. Maybe it's gonna, if value is numeric, no. Please, what did you think we can use? Please, let's reason together now.
The is numeric has to be together.
It's numeric, it's digits, it's numeric. Yeah, I think it's numeric.
No, but you spaced the is and
okay,
numeric.
I spaced it. Let me see if it's gonna work.
Even the is digits, they are together. And I think you should just
yeah,
use
they are together. I don't know why it's not bringing it up.
But
it's
you can
numeric.
write it. You can write it and it will come out.
You can see it's numeric. It's not coming out. That is the problem. It's digits. Okay. Oh. No problem. So we'll look for a way to find that. Don't let us waste time on that. But we should reason for a way of bringing this out, and changing these values. But now, if I inspect by ordinary inspection, there is something I can do. I can check if I have I in it or if I have O in it. But the condition I want to consider is, what about if I have thousands of entries that I cannot see? Do you understand? Now I know I can easily do this. It's easier. But what about if I have thousands of data, of entries? How do we isolate those that are not numerical?
Sorry, can I suggest something?
Yeah.
On the code you were writing, if studf1 english.values is digits, then print. Yeah, from
okay.
Yeah, from
does value.
Yeah, just bring if then you bring from studf from copy from studf from to the end of then bring it down. If the whole of this thing is digits, then just put dot is in front of the value ahead. Dot is
digit.
Dot
Okay.
is digits.
It's not bringing it out. That is the problem.
Even the numeric, even the is numeric is not coming out.
Yes, so that is the problem, and there is a way we can do, and it's I don't know, sometimes let me see. I have a code. Let me copy that code somewhere. Let me check my library and bring out a code. Okay. Okay, I've gotten a code from my library. Okay, let me use that. But now if I get this code, all we have to change is this column that then we will manipulate and see how we can make it to what we actually want. Okay, we say numerical digit is equals to student, okay, this. If, okay, for this, numerical digit is this, okay? If for value in columns, numerical digit is equals to this, that is this digit, then we can print numerical, okay? If values, okay, we now have a numerical, right? So now if value not in, if value not in numerical, not in this numerical, this thing we define, if value is not in this numerical this thing, then it should append that value in the okay, I not put, later we explain, append special data string dot append value. I think this should work. Does append value. Let me run so that we can explain again. Okay, I think this worked perfectly. What we did here was that we define an empty string. Like inside this English core, we are looking for we define another numerical digit, and we say that numerical digit is equal to the English score into those ones that are digits. If it is not a digit, and then we give it a name, it means every value in English score will be seen by this name. But if it is not a digit, it's not going to be seen by this name. Now, we now run that like if, what happened here again? We now run that if we check this value and it's not in this, if there is any of the value that is in the numericals, that is in the English score, that is not in this numerical digit, it should append that only one. I think that should work. So let's try and print out this special digit now to see what we don't have. Oh, it's not as okay. It's not isolating them. We have this, we have that, we have no. It's not all what we want. If you check the value, okay, there are two things we are considering. Let me still remove this. This. But I think something is working better here now. Numerical, check the special character as empty, define this numerical digit as this, the string does this. So let's first print a numerical digit before we start manipulating. Sometimes you have to be doing your code one after the other before you can start to manipulate. So let me see what the numerical this thing will give me. It should not include, okay? Now it's telling us that all these are false. That is, they are not numerical. Okay?
Sorry,
It means the first and the second one is false, right?
Abdul,
yeah.
Excuse me.
Yeah.
Can you see the chart?
Okay, let me check.
Check. There was something I wrote on the chart. Can we try and see if it will work?
Okay, this is the digit. Let me just copy it. Okay, this is what you have. Thank you. Let's see. Now, you're thinking we have digit list, okay, which is good. Non-digit list, which is good, okay? Okay. For value in students, dots, student did dot values, dot values.
No, not dot values. Don't call them, just their student scores.
Most time it is appropriate to put the dot value. Especially if you're gonna run it in though it's still working this way, but anytime you are running stuff like this, always use dot value. If value dot the value, this not this value we are talking about, you understand, is the value that is you are converting, you are checking the values, is just a keyword. Okay, you can see where I was writing it before I was putting that keyword. Is a keyword, is a good practice you can always do. But before I do that, let's just continue with what you're saying.
Okay.
Now we say this digit list, we have this for value in this. Okay.
Please help me put the column in quotes. I forgot.
Sorry, I'm coming. I will do that.
Okay.
For value in this, if value dots is digit list append value S. Okay, I think this is good. Which one did you say I should put in code?
The column,
yeah, the English is not even in code as well. Yeah, this is good. Thank you for helping us. Okay. Which one did you say I should put in code again?
No, that's it. Value. Wait.
You see, the problem is that you see this is digit have to be in another what do you call it? This should have run well, but this have to be it has to be highlighted with another, you see, like a keyword. Do you understand? So, and that is the problem. So what you have written should have been a good one, but it's not coming out that way. So let's still work on this.
Okay.
Now we have this. You see false. It means if it is false, so we isolated it, and it means it's only the first two that are false, which shows that they are not numerical. If you check very well, you will see it is only these first two that are false, and that is what I want. Those are the first two I want. Now I will now come here and say if false, let me just say if numerical equal false. Let me just say this and see if that's I need to have a value for value in numerical in this. We are only talking about the value in here. Or we just say if false. For values in this, for every values in this, if false, let me say, if false, what will happen? Oh. Let me print false again. Let me just print value and see what I will get. Sometimes it's better you do them one after the other and come to just print the value alone. Let me run this and see what I get. Oh, it's not giving me. It's not false. Oh. One thing is that we have been able to isolate those that are not numerical, and that works. The only thing we have not been able to do is to actually isolate this out, those that are non-numerical. And how do we get that? This is working. There is no problem with that. And we get false, false, and false. We want to isolate those ones that are false from and append it in this. That is the major problem we have. But okay, in our next class tomorrow, I will find a solution to that. So let's just continue. Now, if we are able to isolate that, all I will do is to say, okay, remove this O and remove this O and put 0 to make it 50. Or remove this and this other one will give me 4i. I will now say remove the exclamation and put 1. I want to assume that that is going to be 41. But apart from using you see the problem with using what do you call it? With using type conversion, if you use this type conversion, this problem can be overcome using another type conversion. You see, we use students dot as type float. If you are not using as type float and you are using another type of type conversion, it's going to convert it. But in that case, when it's converted, it will change every other thing. All these two is going to change them to NA, non-value. Do you understand? So there's another type of conversion we can use without going through any headache of converting, of getting all this thing out. We just say, okay, convert it, it's numerical. By the time you use this numerical is going to solve the problem we are trying to solve. So how do we use its numerical? So let's quickly use its numerical instead of any other thing so that you can see how its numerical work at converting to NA. Its numerical will work perfectly without even stressing ourselves, without any other thing. So how do we use its numerical? So the first time we have been able to use what do you call it? We have been able to use type, but now we want to use its numerical. You'll discover that the difference between this type conversion and its numerical is that in the using of its numerical, is going to undo any other special character in it. So let me quickly use that to undo the special character. Let me delete this since we don't need this for now. I will ensure I work on this when I get after the class. So what I want to do now is instead of using, let me copy the two codes so that you see what I'm trying to say. This was the code we tried to use on English, and because it's having a special problem, a special character, it flashes an error. So we can use another type of type conversion. This one we convert using as type to float. We always flash an error because anytime it encounters any other thing that is not digit. But if you use this one, apply its numeric, it's not going to flash an error. So let's copy the code, the same thing, and use apply type. That is the only thing that is different. The apply type, we not we just convert everything. So by the time I say it's numerical now, and I run this, if I run this, I'm going to get an error because it's having a problem. You understand? Which we have not been able to identify. We have been able to identify it, but we have not been able to remove it. But if I run this one, there will be no problem. It's going to run. Why? What is the problem? It's numerical. I don't know why it's numerical is not running here. I'm not sure if it's numerical is still working. Apply is numerical. I don't know if Python have upgraded from its numerical to something else. That is the problem now. It's numerical. It's numerical is you can use it's numerical, but it's not working. Maybe it's deprecated. I don't know. Let me see. Let's go. So I don't know. I will find out. So let's just continue so that we're not going to stay here forever. Okay, yeah. We are supposed to import, yeah. We are supposed to import, yeah, I got what the problem is. We are supposed to import. Before we can use is numerical, we are supposed to do some import. And in that case, what we are using is called, what is the right name for it? Yeah, we import regular expression. Yeah, before we can use this numerical, we always import regular expression. I think that has been our problem so far. We import regular expression. If you don't import regular expression, you will not be able to use this. But what again? Okay, it's not working. Now tomorrow we're gonna work on that. So what we did was that we tried to convert from one type to another, but we are still having problem with this. We'll come back to that tomorrow. So after we have done that, the next thing we think we can do now is to check on the missing data. If we run our F1, we say there are some of them that already have missing data, like all this NA. How can we undo the missing data? We say handling the missing data, there are so many things we can do on them. If we want to handle the missing data, one of the things we can do is to delete, yes, dropping rows with missing data. So if we want to run this, we can drop all the rows that has a missing data. So if we have, but before we do that, let's have like let's copy this F1 to like 3 different stuff. Student 1, student 1, student 2 is equals to student 1 dot copy dot copy. So if we run it, it's going to copy it. Let's run again for student 2. Let's just do it for, let's just copy. In fact, let me copy it from the original student data. Sorry, data. You see, there is an original one we didn't touch from the beginning. We didn't touch that. That original one. Let's just copy student 3 again. Let's copy student 4. We are trying, because we want to manipulate now. Because of that, we want to try different things on them. So the first one we are going to try on, is we want to drop on student 1. Let's print everything. You will see that everything for now is the same. Student 1. Okay, let's first try on student 1. Okay, student 2, student 3. Let's say student 1, let's student 2. Let's see what we got. This is what we got for student 2. Let's see student 3. Let's see what we are gonna get. Is the same. Let's see student 4. Let's see what we're gonna get. You can see they are all the same data. 2, 3, 4. Now we want to start manipulating them one after the other. So the first thing we want to do, we want to drop every rule that contains missing values. If you check this, you will see that all these rows contain missing values. If we are to drop, it means the only one that will be left, this one will be dropped because it contains missing values. This one will be dropped. 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 And this one, okay. The only rows that will be left is going to be 8 and 9. And you will see that that is not going to be a good method. If you are dropping everything that has especially when your data is not large. So let me just say 2. I want to drop everything that contains so if I go and print the student 2, I will only have 2 entries because everything contains, you can see I only have 8 and 9. So I only have 8 and 9 because they are the only one that don't have any non-value. Because if you check from the original, you can see the only one that has no non-value is only 8 and 9. Every other rows has a non-value. So we say this method is not good at all times. There are cases where they are good if you have a very large number of data and just a very significant one can be dropped without affecting your data. So you can drop them. So you can drop everything totally. Another thing we can do, instead of dropping, we say we can replace using median. We can use median, okay, for example, depending. Control-C. If I copy this one up, we can no more use we have used F2. Let's use F3 now and see. This time around, we want to use median. For, let's see, F2, for a particular one, or for all of them, let's use for geography, let's use median for it. For geography, okay, geography of F2 now. Okay, F3 this time around. For geography of F3, because you cannot use F2 again. For F3, if you replace it, it's only going to change for geography. If you call on your F3 alone and you check, you can see the geography has been replaced. All NA in geography has been replaced with median. For the same thing, for the same F3, because the F3 is still good, let's check another one that has NA. We have a column of on English score. Let's use what can we use for that? We use median. Let's use mode for that. The only thing we just change is that we just change this one to mode. And run. Okay, no, this time around it's not geography again. We are running on English score. We want to change every English score, everything there to the mode or median. Let's change this to median. Which one do we use first? Was it mean? So that, okay, we use mean. Okay, median. Let's use mode for this, okay? Mode for English score. Let's use mode for it. And run. Okay, if we check on the data of this again, our time is going. If we run, we are having under the English score, there is no more NA. All the NA has been replaced with the mode. Let's check for our error. Under error, for the same data, which data are we still using? This time around, for the error, we have used median, we have used mode. Let's use main, right? We just copy the same thing, and we are going to use main this time around. We use main for this one. We just change to main. Yeah, main. And this time around, we want to change everything, the NA from in our error to the main score. So it's going to change all the errors here, the NA to main score. If I turn it this way, I turn it this way, and I run, it's going to run. I bring the student data tree, I check, I duplicated it so that we can reuse other data. So you can see everything here has been changed to what do you call it, to the mode. I don't know what we have used. So in this, there is no more NA, which we can check. But before then, now we have completed this method. We say in our method, if we want to check for NA, the method we can use to check for NA is to delete all NA. So, which we have used. Another thing is that we can replace all missing value with a median. We have done with mode. We have done with mean. We have done. We say we can also replace it with what do you call it? We can also replace it with a random number. We have done this type, so don't need this again. We can replace it with random number. So how do we replace it with random number? Now we are going to call on another data frame. We have used 2, we have used 3. There's another one we call 4. So let's call on student 4. 4. So if I call on student 4 now, you can see this is what we have on student 4. So all what we want to do now is we want to replace with a particular number. So let me just copy this and put it under it. This is student 4. Okay, this is student 4. I can't find it again. Okay, this student 4. Okay, now we are saying on this student 4, let's replace them with English score. For example, under this student 4, the English score, let me see. Let's decide, okay, anywhere you see NA, replace everything with 0. It's going to replace everything with 0 or with 10, with anything. Let me just say, okay, replace everything with 10, for example. It's going to replace it with 10. So if I call on this, all the English calls NA will have been replaced by 10. So you go to English call, there is no more NA. All the NA has been replaced by 10. You can do the same thing with other. Let me replace everything here by 0. Let me replace everything here by 1. So that is how to replace with random number. So we have done the random number. We have replaced with random number. Now, another thing we can do, we say, apart from replacing with random number, replacing with apart from replacing with random number, median mode, or deleting everything, there's another thing we can do. We can fill forward or fill backward. What we mean by fill forward is that everything, okay, for example, let me call on 4 again, because that is the only one that is not totally messed with. So let's call on 4. Yeah. It's like we have done that last week. I'm just trying to check the code. Okay, we don't have it. Okay. Now let's check on 4. Student 4. Now, if we have this student 4, we say we can use FA. These are the other things we can use. We say we can use fill forward, fill backward, use interpolation. I said interpolation is majorly used for time series. It's majorly used for time series interpolation. But we can fill backward and fill forward. What do we mean by fill backward and fill forward? This, if it is feed forward we want to use for this NA, for example, under geography, is going to look at the number before it and use it. It means this NA becomes 60. And this one, that is this NA becomes 34. And if this one becomes 34, automatically this becomes 34, this becomes 34, because we have this is the actual a real number before then. But if you are using the feedback one, it means since that it's going to use the number after it. So we have NA. So this NA automatically becomes 85. This one automatically becomes 93. That is the number, the immediate number before it. That is how to use fill forward and fill backward. So we can quickly demonstrate that. Let me check my code. It's almost our time. The only thing we want to do now is fill forward, fill backward. Let me just copy the code and drop as a summary because the time has gone. This is a summary of what we can do. Let me just copy this here. So we've done fill NA. We can fill it with 0. It means it's going to apply to everything. If you fill everything with 0, this time around we are not isolating the code, and we are not isolating any column. Every NA you find, fill it with 0. Of course, you will not want to do this. You may want to isolate each column. So you have to isolate the column. And to isolate column, you just have to come here, change it, and put this, and put the column you want to isolate from it. So it's only going to fill this column. But if you don't put it, it will fill everything. If I put this and I put the column, I just put the column, that is going to be the name of the column you are going to put there. Of course, you should put this to indicate that, okay, this is the column. Okay, so the F is the name of our data frame. Now, so you just say fill in here method. If you and you see filling non-value with the previous ones, which I've just explained. Okay, this one filling NA method BF, that is before it, filling non-value with the next one. If you try it, you will see the one that is FA, fill forward and fill backward from it. Then fill NA with method. Okay, we have done this. Replace. Of course, you can as well do the same thing. You can use replace. You can use the data, that is your data frame. Instead of saying data, let's just use the same data frame and dot replace. Replace every NA with value. You can just put the value of what you want to put in this. You can use this as well. Or 99 minus 99, 100. This is the syntax for it. You can also use interpolation, but this one is only used for is majorly used for what do you call it? Time series. Of course, we have different type of data. We have data that are referred to as time series data. Then you can drop NA, which we have tried before. So, and then drop, of course, you can do it for a column as well. If it is only considering, you only want to consider a particular column, of course, or you can do it for all. The same thing with this. Dropping row in all value. Okay. that has a, of course, you sometimes, you can just give some reasons, like say how you want it to be declared. There are so many things that can be here. In this how there are some other arguments that it can take. So for now, for today, we're gonna stop here because of our time. Thank you for coming. Believe by tomorrow we'll be able to continue from where we stop.
Yeah, thank you, Abdul.
Yeah.
Thank you very much, Abdul.
You're welcome. It's a lot.
Yeah, thank you so much. And yeah, let's continue tomorrow, guys. Have a good evening, everyone.
Sure. Thank you. Just one question. Will you say, will this recording be sent over to us?
Of course,
Okay. All right. Yeah. Yes.
the recordings will always be available on the website.
Okay. Okay. Got you.
Yeah.
Yeah.